in this video, we'll be talking about types of vectors. So there are mainly 9 types of vectors. Those are polar vectors, axial vectors, equal vectors, unequal vectors, parallel vectors, anti-parallel vectors, collinear vectors, zero or null vectors, and finally unit vectors. So let me explain them. So first up, we have polar vectors. So what are polar vectors? They are vectors which have an initial starting point and a final point of application. So two common examples are force and displacement. So let me explain how force and displacement are polar vectors. Now I've set up an example here. So there's this mouse here and a bucket here. So applying force on the mouse, well, makes the mouse hit the bucket. So force is a polar vector since the starting point and a point of application. So the force is being acted upon the mouse from my hand, which is muscular force. So since force is mass times acceleration, and acceleration is basically uh, v minus u by t, that is rate of change of velocity, and velocity is displacement by time, displacement is the shortest path. So since displacement is a vector and has a starting point and a final point of application, this becomes a polar vector. Next up, we have axial vectors. So what are axial vectors? Well, they are the vectors which depend on the axis. So say axis. So these represent rotational effect and acts along the axis of rotation. So assuming this is the axis, they go like this, right? So they represent the rotational effect. So some of the common ones are angular velocity, angular acceleration, and torque. So what is angular velocity? Well, if you take velocity on a straight line and convert this straight line into the circumference of a circle, that's angular velocity. So rate of change of angle. And angular acceleration is, well, the change of angular velocity with respect to time. So at one point this can be going at say x meters per second, and then on a circular path, of course, and then here this can be going x plus n meters per second. So it can be accelerating in both ways, as in direction and speed. So that is what basically velocity is. And torque is, well, something else. So it is the distance here. Let's take this door hinge and the top view door and a doorknob here. So torque is force times distance. So Newton meters. So if you've seen, I'll demonstrate it. Applying force here on a door is to open it is much difficult than just doing it here. So let's see it practically. So now I have a door here and I'll be opening it. Now that I've opened it, I'll try closing it from here. Well, it moves a bit. But now if I put the same force here, it moves a lot more, right? So this is what I was talking about. Next up, we have equal vectors. These vectors are those vectors which are equal in magnitude and in direction. So let's assume there is this vector A and there is this vector B, right? So you do notice these are both of around the same length. So length of the arrow is proportional to the magnitude. So that's it for equal vectors. Let me show with a practical example. So now I have a mouse here and, well, I'll be using my two fingers from different hands to push it. So I'll be putting equal force on these both, and the direction I'm pushing is this way, that is forward. So let's see what happens. The mouse goes forward in the same direction, it doesn't change direction. So that's what equal vectors are. Next up, we have unequal vectors. So these vectors are well unequal in magnitude or in direction. So there can be a vector like this, a vector and a b vector. So you do realize length is different, so the magnitude is different. Or we can have a vector like this, vector a and vector b. So this is most probably parallelly shifted, of course, so different directions. And well, the lengths are different of a and b. Or we can have a same length vector of both a and b. That is just different directions. So let me show with a practical example now. So now I have my mouse again. Let me just adjust it a bit straight. Okay, there we go. So now I'll be applying two forces, one forward and one rightwards. So it goes something like this. So that is because there are two forces acting on this mouse. One is forward. So when you see like this, the y-axis is increasing, and there's this one rightward force. So the x-axis value is increasing if we put it on a Cartesian plane. So it goes like this. So that is one thing. Now we have this mouse again. I use my two hands but give unequal forces. So it turns. This is also an unequal vector. So next up we have parallel vectors. So what are parallel vectors? These vectors are parallel to each other and well they act on the same object. So these can have the different magnitudes but have the same direction. So these are parallel vectors. Now let me explain with an example. I have my mouse again, so I'll be applying two forces. Of course, both are unequal but in the same direction. Both are parallel. So you see my fingers are parallel to each other. So since this finger is giving more force, it turns left. So those are parallel vectors. It's in the same direction but of different magnitudes, so it changes direction. So next up we have anti-parallel vectors. So these are also known as opposite vectors since they act opposite in nature. So let's take this as a common point for both tails, and then there's this one. Let's call it A vector and another here. So let's call it B vector. So these are opposite. So they have 180 degrees as their angle. And well, their magnitude may not be equal. So these are opposite vectors. Now let me show it with a practical example. So I have my mouse again and well, I'll be pulling them. So I'll be pulling one with one hand this way and the other hand this way. So first up we'll do with the same magnitude. So well, it remains. The both forces are acting opposite and with equal magnitude, so it remains stationary. But now let me use this hand to pull more, as in with a higher magnitude, and this will pull less. So it moves this way because this hand is pulling more when compared to this. So the net force is in this direction. So next up we have collinear vectors. So these vectors lie along the same line. So let's take this line for example, right here. And then there is this one force acting on it. Let's call it vector A. And there is this another vector acting on the same line. So let's call it vector B. Since they are in the same line, acting on the same line, they become collinear vectors. Next, we take another example. On the same line, of course, there is this vector acting this way. Let's call it vector A. And there's this another vector acting this way. So let's call this vector B. So depending on the magnitude, the object will move or remain stationary. So let's see. I have this mouse again. So first let me put one force here let me do it this way so it's more easier. So I'll put one force this way and another force in the same direction on the same line. So, well, the mouse moves forward. But now I'll apply one force this direction and another force in this direction. So if both are of equal magnitudes, the mouse remains stationary. But let's say this hand gives more force, so the mouse moves. Since these both forces are acting on the same line, the mouse moves. So that's why these are called collinear vectors. Next up, we have zero or null vectors. These vectors are having magnitude 0. So if magnitude is 0, their displacement is, well, 0 because they can be in any direction, but how far they go is 0. So they're practically stationary. So velocity of an object at rest is again 0, but it has a direction, right? So it doesn't matter which direction it goes in because since the magnitude is 0, the direction does not matter. So the direction is not specified. So, well, let me explain it with an example now. So now I have this mouse again. So it's at rest, and well, there is no displacement of it because it's not in motion. And then there is no acceleration, or acceleration is 0 because again it's not in motion and there's no change of velocity. So, well, since it's at rest, it is a 0 or null vector, and direction doesn't matter because it's not moving anywhere. Next up, we have unit vector. So, usually unit refers to 1. So, this vector is of magnitude 1. So, how do we represent this? Let's take a vector A. So, because its magnitude is 1, we just put a cap on top of it. And this is a unit vector of A. So, to represent any vector, it's a multiple of a unit vector. So, let's take 5 newtons, a vector of 5 newtons. So, this is basically 5 times this. So, this is the magnitude. So, if we just do 5 Newton this way and put an absolute value of this, that's basically the magnitude. So this is the multiplying it, and this is the that this gives the direction. So magnitude 1 will give you, well, the speed or whatever you want to be velocity, but direction is specified since this is a vector. So 5 newtons, this is 1 Newton vector this way, and just with this times 5. So that is what unit vectors are. Hope you understood what are the types of vectors. If you enjoyed it, liked it, so please share. Thank you.